Hello, ATS 570 students. This is Dr. Shragi, and I wanted to show you a little bit about a concept that we're working with right now in our class called convolutions. A function, a convolution is an operator, or whatever you want to say, that acts on one column of data to produce another column of data. For example, here, this function c that I have here, c is a convolution. It is related to another function a and another function b. A is a function that is, it has a value associated with each time that we took observations or whatever. So like there's AI, where I goes from 1 to, I guess, 250 is how far I went. So from A equals 1 to, for A equals I from 1 to 250, there's a value of A. There's also a set of weights called B in this case, where B is a function that has values from j equals negative k to positive k. K being like our half window size or whatever. So in this case, for example, I made a list of values that I'm calling B that go from j equals negative 8 to 8. K is equal to 8, and we have 2k plus 1, or 17 weights right here. But they're just two functions. They could be anything. We're going to see how they apply to things like running means and how they apply to things like filters in a little bit on a different video. But this little operation here is called a convolution. What we're doing here is we're computing each new value, c sub I, as a function of the values of a that are centered on I but go from I minus k to I plus k, each of which multiplied by b of j. So, for example, I kind of graphically illustrated this down here. To compute the first, c of I does not exist for the first k values because this is not defined. You would have, if you had, for example, c of 1, you would have then I of a of 1 minus k. Well, that's not defined. There's no values 1 minus 8. So if we start at the k plus 1th or 9th value of the data series, we get this one right here. So the value right here at C9 will be equal to the sum this value of A times this value of B plus this value of A plus that times that value of B plus this value of A times this value of B. See how we're using the A values starting at 9 minus 8 and going all the way up to the values of not at A of 9 plus 8. And each of those we're multiplying by the value of B, going from B of negative 8 all the way up to B of 8. Now this could be done kind of in a clumsy sort of way, but we're going to see that there's a nifty function in Excel that does this for us. But all that will do is give us this value right here. That would give us, I'll just type in here, C of 9. Then we apply the same idea to the next row down. So for example, if I just move these guys down, again, I'm just showing you this visually before I introduce you to the idea of how this works in Excel. To compute C10, I is now equal to 10, we're going to be adding the products of A10 minus K, B minus K, all the way to A10 plus K, BK. So to get C10, we're going to be adding up this value of A times this value of B plus this value of A times this value of B all the way down to this value of A times this value of B, and that's going to give us this number right here. And we're going to keep doing that for each of these spots. We're going to have a way to do, we're going to compute C at 11 and C at 12 all the way down through all the possible combinations. This is called a convolution. In Excel, though, there's actually a fairly straightforward way to do this that's actually pretty clever. It's called sumproduct. SUMPRODUCT. Let me show you here. The sum product is a built-in function, equals sum product. And what you do is you choose the values of A that you're multiplying, these 17 values here, comma, the values of B that you are multiplying, and it will then compute this one minus times this one plus this one times this one plus this one times this one all the way through there, and you get this value. Now, I could then take this that I have right here and copy it. I'm only going to copy it down one cell because I want to show you that there's a problem. If I notice our old version, old function here. It was the sum product of the range B23 to B39. That's B23 to B39. And we're doing the sum product of that with D23 to D39, which is these values. But because those were relative references, when I copied that down one more cell, it correctly shows that now our A values are from B24 to B40. That's these values right here, which is correct. But it also transferred relatively the values of that B matrix. So now the B is from D24 to D40. Well, D40 isn't defined. It's this value right here. What we have to do is we have to change these values in our original function to being absolute references. We want to stick with the values of B that we're working with are absolute references to this range right here, D23 to D39. Now if I copy that down, notice that the equation that we're getting for C10 still uses D23 to D39 as the range of weights. And in fact, I could take this value here and copy it down all the way through my formulas here, skipping the last K cells because the values aren't defined there. Let's see, how close did I get? This uses up to B270. Let's see here. We're using B258 to B274. Well, D274 is 2 past the end, so it must be here. All right. So, like, for example, this last value of C at 242, is the values of B from 256 to 272. That's these values right here. Times the values of D23 to D39, which are these right here. Okay. So this function C of I is now a convolution of A and B. And this is going to be pretty tricky and neat. This is going to be a useful trick to use in filters and running means and so on. Equals sum product is a powerful and important tool in Excel. So make sure you understand what you saw here. And if you have any questions, please let me know. This has been Dr. John Schrage.